Okay, today's video we're going to talk about capabilities of the shop. What I use to get surface finish, precision, and the quality out of the parts that I produce. This is this week's work. Heat exchangers, actually. So we're going to pump glycol into one side and out the other, and internally on these guys there's a whole bunch of passages. So this is going to be gasketed with a Loctite product, actually. Very thin film of material spread around the perimeter, and then 3mm bolts will lock it together. So this gives you an idea. My hand to give you an idea of the scale here. And I don't like to touch my stuff, but surface finish is a little rougher on the mating surfaces because we want that gasket material to actually bite into something, but it's still quite smooth. And then that's the tool pathing on the top side, and that's just to relieve some areas. Lighten the part up. This is going on the bottom of the telescope, so if we add a ton of weight to this thing, we're going to have balance issues. And I still have to drill and tap the fittings for G quarter-inch fittings. So there'll be a rubber O-ring sealed straight thread. So yeah, on the bottom side that we're going to attach this to the structure to cool it. You can see this finish. It's pretty decent. And then this side we have all the passages, and they're deeper on the bottom piece than they are on this top piece. This is where the bulk of the material will flow. So if I put this down, you can see this is either inlet or outlet, and then all these millions of passages through here. Drilled and tapped blind for 3mm. And again, this is this week's work. This one was a little tough to do because it's a little harder to hold in a vise. But surface finishes on everything, quite consistent. This one's real small. So yeah, that's what we do. And again, this is a week's worth of work or so. You know, there's 2 setups, 4 setups, 4 setups, 4 setups. There's a lot going on there. Now, as far as verifying that we're within our spec, and these are pretty light tolerances. This is not anything that's super critical tolerance-wise. But, you know, I do have a pretty nice Mitutoyo height gauge here, and an old school Brown and Sharp here. So, pretty cool stuff. And not to mention, you know, a pretty good granite to do the work on. And then over here, I've got a toolbox that's filled with some pretty high resolution electronics. These are just big calipers in the box here. In here, it looks like a whole bunch of bore gauges. I got one depth mic there. Up here we've got force gauges and thread micrometers, inside mics, disc micrometers, precision balls. But yeah, this is how I get stuff done. Inside mic there. A little bit of a mess in here, but not too bad. And then out in the main shop, I've got a cabinet that's full of little tools. So all my mics are in here. These are all old, but really nice, really high quality. And I constantly keep them within spec. Positioning jacks, all kinds of big 246 blocks, V blocks. I've got a bunch of tapping fluid and various other little things up top here. Fun toys up here. That guy's out on the machine right now, but just boxes filled. Gauge blocks, hole saw set. This is all abrasives for doing fine bench work, deburring and whatnot. I got a really nice adjustable broach set. All my big Deming drills here. This guy is filled with carbides, resharpened stuff. A lot of my metric stuff I keep in here. And in here we've got a whole bunch of taps. These guys are all thread forming taps. Very small stuff for doing copper. And more taps over here. Very small stuff. And then a bunch of reamers in here. And behind here I keep a set of those, and a little folder of reamers here as well. There's all my collets. Pretty nice set. I got all that stuff there. Super handy. Shop is a bit of a mess right now because I've been just crushing it this week, but did manage to get a new decal for the lathe. Anyway, got a brand new Accurite on the lathe. Helps me maintain good accuracy on that guy. Keep my tools up and modern here, which is kind of cool. When things get a little old and flaky, we step into the good stuff. So we go from Accurite on the Nardini to this little maxi mat. All I do is old school, and I have a magnetic base that I can put on this as well, and measure the slide as well. You can go down to the dials, but I really think I do better work with these guys. We do have an old Spanish-made Jet surface grinder. I think I've got some diamond abrasive in that, and I think I was just on this. I was just turning down some end mills, kind of undercutting some end mills last project. As far as the Bridgeport, old scales, Accurite. I have them on the quill. I also have them on the table, feeding up and down. So I can, even though I only show 3 axes here, I actually have 4 cords going in, so I can just swap out the Z, so I can either measure the quill or the table feeding up and down, which is kind of handy. All right, now out at the CNC, as far as that goes, you know, everybody's got to have this. I got this an 8-inch. I just find it's a little more useful than a 6-inch. And then up here I always keep a little gauge block. This one's 800 thou thick. That just helps me locate parts. Things that, say those heat exchangers have an undercut after I do the first side when I flip them over. I can set this up against the surface and run my edge finder in, and then just adjust by 800 thou, and that's my edge. And speaking of edge finder, this is what I use. 3D taster, and they're fairly accurate. Mine's not wanting to sit on dead zero right now. I find it fluctuates by that half number just based on temperature, just ever so slightly. But yeah, that's how I edge find. And then for setting tool heights, I use this guy. Find it's pretty accurate. It's inexpensive, and for the Cincinnati, it works really well to set tool heights. I have various other things to do that as well, but never seem to use them. There's the refractometer for coolant. We went over that in a previous video. And I always keep a precision square out here. I think these are those, yeah, there you go. Spring parallels. Whole pile of collets. I think ER16 is pretty much all I use. Thick parallels. I got some thin as well on the inside of the shop. I keep a couple out here. A lot of that. Little blocks for various things. Some plastic for holding things down without marring surfaces. There's my carbide. We'll go over that. Edge finishing. Okay, back in the inner shop, I've got one more cabinet in here. And here you can see all of my gauge pins. Bearing heater, Cerakote. We've got a little bit of Mitutoyo stuff, which is pretty cool. So it's everywhere. If there's something I need to measure, I can pretty much get it done. A lot of various bases, stuff just laying everywhere. It's an old Fowler. But yeah, I've got a lot of gauge stock on hand. It's pretty much this entire row is just, I said gauge stock. Pretty much this entire row is just shim stock. A lot of brass, there's some plastic, various things. Tubing for the CNC in case we lose some of those lines. Down here I've got spring washers, Belleville washers, a whole selection of kind of odd, weird stuff. Foam cutter, a little bit of welding rod, some very specific stuff that I'm keeping for the hot rod project. This is silicon bronze, and yeah. Okay, that last heat exchanger job that we just did, this is some of the tooling that we would have used on that. Helical, see if we can get this open. It's a 1/2 inch, 30 thou radius on the corners. 4 flute. I think I also used some 3 flute stuff on that. Just allows me to feed a little harder and get through it a little quicker. Here's something I used for tight corners with a big depth of cut. Ugh, there you go. It's beautiful. Real high helix, 3 flute, 1/8 inch, and you can run this pretty hard. Oops. I also used some Harvey stuff, and this was a 3 fluter, real small, that I used on cutting some of those deep passages for the material to flow through. So this is a 3 fluter, a little shorter so you can really get after it. Yeah, real high quality tooling. Super important to get those nice surface finishes. I really like the helical stuff because as you can see, if you pull this tool out from its holder, you can actually just scan this QR code and it'll take you right to Machining Advisor Pro, Speeds and Feeds PDF calculator, sim files, just pretty much everything you need to figure out how to run this thing at its optimum condition. Okay, also I can't stress enough that what I do out on the CNC machine is totally reliant on good software, and I use Mastercam. So as you can see here, this is that last part we did, the top piece of that last part. Flip it over, there's the bottom channels. So this was all designed in SolidWorks, imported into Mastercam, and then we do the tool pathing here. And I use, initially to rough this guy out, I used high-speed dynamic OptiRough, and we can see that there. Went down a few levels with a big 3/4, I think. And then we started cleaning things up with smaller and smaller tools. Oh, you can see I did the face right there on the top of that. And then this is probably facing the other top there. And then we come in and we do at a really high clearance plane set there, which is not necessary, but I just went with it, didn't matter. Again, everything I do here isn't time dependent. You know, you want to be as efficient as you can, but if you waste a little time on something, it's a one-off part. Everything is a prototype here. So you can see the tool path that was provided by that high-speed area roughing. Really nice tool path. Gives us a nice finish. And then that's a finish. And then this one was basically bringing this other top edge over here, right? Oh, I can't even click on it. Anyway, you can't see it, but anyway, bringing that other face down. And then we go through a whole pile of contours, getting the edges right, drill all the holes, and in the very end, way down at the bottom here, I've got some 3D high-speed spirals, and that's what's getting a lot of the little round pockets that you saw, kind of right in that area. There's little round pockets, and those will be for hold downs. Little screws are going to go and have springs, spring-loaded screws that push on this thing and constantly maintain pressure, no matter what temperature difference, how much the instrument expands and contracts with heat and temperature. There will always be a consistent pressure pushing that against the surface. And there'll be a thermal paste used that'll help extract the heat out of this thing. So everything in astronomy is heat related, I think. So there you go. Let's turn all those tool paths off. Now they're all on. Now they're all off. I can go down and turn one of these guys on. Boop, right there. So that's all that little tool path did. Used a 3/16 ball to do this work with right here. Pretty darn cool. So with all those tools, our raw material comes in predominantly, for the most part, by a large margin. I buy everything from Dick's Metals in Huntington Beach, California. what you ask for is what you get. The stuff's very square. They call them machine ready blanks. I can have things blanched ground to whatever thickness I ask for. A lot of stuff I do is metric, so I'll just have material brought in at the thickness I need, and then I just cut the profile out, drill the holes, and do whatever else I need to do. But yeah, Dick's Metals, couldn't do it without these guys. Happen to be in education. We're a nonprofit, so we get great deals on a lot of stuff. A company with a budget like this, we wouldn't be able to do the Mastercam thing. So we got to thank those guys, and I lean pretty heavy on MCAM Northwest for advice and training and whatever pointers I can get. We're always learning, so you got to keep pushing. And by that constant pushing, keeping your ability to measure, to machine, and keep your surface finishes up, we're able to produce this kind of stuff with relatively very little equipment. It's a one-man shop, and yeah, we're able to churn out some really beautiful stuff. So that's pretty much it. I mean, showed you some on-screen stuff, but it's an Alienware laptop. Nothing really special. I don't have a 3D mouse or anything like that. I do at my engineering studio inside the main office building, but for what we do out here in the machine shop, that's a great little laptop. It's magnesium cased, it's very durable, helps with cooling, I think, so I use that guy. Like I said, Mastercam, great tooling, good things to measure with to prove that to yourself that you're keeping your tolerances within check, and that's what we do. So it was a slow day, or a slow week rather, out in the shop. So I thought I'd just do a quick little video to show kind of what's been going on. So more to come. I'm going to finish up this heat exchanger project and then move on to the next thing.